Momentum and rotation review 2. If V naught is negative 2 meters per second, find VF. See the graph. Let's look at this graph. We have net force on the vertical axis. We have time on the horizontal axis. And whenever we have force and time, we need to remember that the impulse is equal to the change in momentum. Impulse is symbolized with a J for some reason. Another expression for impulse is the integral of the net force dt. What does that tell us about our situation here? I think, aren't we looking for the area under the graph? And then what's this right side going to be? The right side is going to be the change in momentum is the mass times the quantity VF minus the initial. Let's see if we can do that. Find VF. We're assuming we have the whole time here. We're not told otherwise, so we're going to go all the way to 6 seconds. So let's find the area under here. I'm seeing one triangle, two triangles, and then a rectangle in the middle. Let's see what happens. 1/2. The base is 2. Let me check units. Seconds and newtons. All right, good. So we'll show units at the end, but I like to check them to make sure that everything looks good. The height of this is going to be 20. What about the rectangle? Width is 3. Height is 20. What about the other triangle? What's its area? 1/2. Width is 1. Height is 20. All right, what's that come out to? This is 20. That's 60. Let me scribble these in so I don't lose myself here. That's 20, that's 60, and that's 10. What's that come out to? 90 Newton seconds, which is the same as a kilogram meter per second. So that is the left side of this. What's on the right side? The right side is the mass, which according to right above the graph is 15, and then V final minus, be careful, V initial. So in effect, we end up with VF plus 2 here. So can we do that? 90 divided by 15 is 6, and then subtract 2, I'm thinking positive 4. You check and make sure on that one, but I think that VF is going to be positive 4 meters per second. So it looks to me like the object has changed direction when we've been applying this force to it. You see, the velocity was in the negative direction to start with, and the force is constantly being applied in the positive direction. You see that? Because these forces are all positive. Let's look at the next problem. We've got a 2 kilogram mass, and it has the momentum time function given there, and we want the net force on the mass at t equals 2 seconds. So we need to remember here that the net force is the time derivative of momentum. So we need to take the time derivative of this. Whenever we take derivatives, we power down. So that's going to be 6t squared minus 8t minus 2. And then we put t equals 2 in for each of those. You put t equals 2 there. That part comes out to be 24 minus 16 minus 2. How much is that? 6? 6 newtons. Positive 6 newtons. So it would be in the positive direction, whatever that direction is. What about the acceleration of the mass at 2 seconds? How many times have we used this equation, Newton's second law? At 2 seconds, the net force is 6, and the mass, we're told right there in the upper left corner of your screen at this moment, 2 kilograms. So what's the acceleration? Do we need a calculator for this? I hope not. 3 meters per second squared.